Hello viewers, welcome to this video lecture series on Computer Networks Lab using the Cisco Packet Tracer. In today's session, I shall give you a demonstration for the static NAT. NAT stands for Network Address Translation. So before explaining all the details of this experiment, let me first make the network topology, that is all the network components that are required to demonstrate this experiment. Then I'll give you once I make this network topology, assign IP addresses or decide at least what IP addresses has to be given, then I'll give you the explanation, right? I'll just drag and drop all the components that are required here for this experiment. These are the different components required to give a demonstration for the static NAT. And also still I have not made the connection between these two routers, because in previous experiments also I said whenever we want to have connection over LAN, we require the serial port, and the serial port is not available here in the router in the Cisco Packet Tracer, but there is an option for us to include that serial module in this particular router and also in this router. So that step I'll carry out now. Click to this, go to the physical. Okay, here is the empty slot for the serial port. Click WIC1T. All these details I have explained you in static routing. So what is WICIT and why do we require, what do you mean by 1T, 2T? All these things I have explained in my previous video sessions of routing. So let us click to WIC, and before you place this serial module, you need to switch it off and then place this and then switch on close. Similarly here physical, switch off this, power off, then you need to place this module, power on, close. Now you can see that you are able to connect to the serial ports. Let us see. So what is that you will be doing? You have to connect the serial DT cable. Now the serial port is appearing. Connect to the serial port of the other router, right? Once you do this, now you decide what IP addresses you will be assigning for all these devices. Let me write here in the labels, then I'll give the explanation also why I have chosen such IPv4 addresses. So now these are the different IPv4 addresses we have decided to assign to the different components in this experiment. Let me explain now about this static NAT. The experiment title is static NAT. We are implementing here network address translation in a static way. We have a dynamic method also to implement the network address translation. This experiment is all about the static method. So what exactly you are trying to do in this experiment is NAT stands for network address translation. Private IP addresses will get translated to public IPv4 addresses. See, always remember in this manner, in very simple way I'll tell you. IPv4 addresses, we have private IPv4 addresses and we have the public IPv4 addresses. Private IPv4 addresses, suppose now I am taking this side, you can see 192.168.20.3, 20.4, 20.5, all these are private IPv4 addresses. So in every class of IPv4, whether it is class A, class B or class C, we have a range of private IPv4 addresses, and in class C the range is from 192.168.0.0 to 192.168.255.255. So from this range only I have selected these IPv4 addresses. So let me consider this as one organization which is making use of the private IPv4 addresses. So now these private IPv4 addresses will not get recognized when they want to communicate with any of the devices in the internet. Like suppose if this devices 20.3, 20.4, want to access this server is here, server is having a public IPv4 address 200.0.0.10. Okay, but this is a private address, so this private address cannot be recognized here in this internet. That means only it is these devices in the network, in their own network, can communicate with each other, but they cannot access any device in the internet. But still we can make these devices communicate with the outside world by translating these private IP addresses into public IP addresses. For that reason only is the entire setup here in order to give the demo for this. So let me just show you very clearly from where to where in this setup is the private site. So up till here. Now this site is your private site, fine. And from here onwards, this interface is having an IP address that is 12.0.0.1, which is a public IPv4 address. You can see this router is having two interfaces. One interface, the fast Ethernet 0/0, lies here in the private site, and its IPv4 address is 192.168.20.1, whereas the other interface of the router, serial 0/0/0 is having a public IP address. So now this router's job is to convert this, which one, this private IP address into a public IP address. So what is the procedure? First let us finish the configuration steps, and then we'll carry out the network address translation steps. And also moreover, you have to know that since these are the two serial, since these two routers are connected, these two routers should have a default routing, and for the default routing we know the procedure. I have a separate video on default routing, so you need to click to the router and go to the CLI mode and type a command here. First enter into the privilege mode. In the privilege mode, what is that you will be doing? You have to write, first you will be taken into the user mode, enable, then you will be taken into the privilege mode, type configure terminal, config mode. Now you need to give the command for the default route for this router, IP route 0.0.0.0, that is the destination network address. The subnet mask is 0.0.0.0.0, followed by the next hop address. So here what is the next hop address we are planning to give? This is what, 12.0.0.2, right? Now this IP route, the same command you need to give it to the other router also. Let me copy from here so that I will save time there in typing. So whatever route settings you have done here for router 0 in the CLI mode, you can always carry out using one more option, that is the config mode. In that you need to go to routing, then type the network address here. So you can type, because you are carrying out the default routing, it is 0.0.0. Then type the, for default routing, the subnet mask, and the next hop address for this router will be 12.0.0.1. Click to add. You can check in the CLI mode also, it is appearing here. This is what we wanted to type. So the same thing what we wanted in CLI we have done through the config. Now let us assign the IP addresses. So first I started assigning with PC0 IP address, subnet mask will appear by itself, and the default gateway is what, this interface IPv4 address. Okay, now you carry out for PC1. What is the IP address you wanted to give? 192.168.20.4, and the default gateway is 192.168.20.1. Next, one more PC, desktop 192.168.20.4, 5. This one will become the gateway address. So now the complete network topology or the network setup we can divide into two parts. This part is completely the one which is in this square is the private side. The other part here is the public. In this public side we have the server, and the server is assigned with this address, and for this server also we need to configure with this IPv4 address and the gateway address. Gateway address is which one? The fast Ethernet FA 0/0's interface address becomes the gateway address for the server. So we'll type the address here, IPv4 200.0.0.10, right, and the subnet mask will appear by itself, and then we have the default gateway, and for the default gateway this one, okay, 200.0.0.1. so once you assign this, close, right, everything, this now only remaining thing is this one. Serial ports has to be configured to the routers. Click to the router, go to the config. We'll use this config method of assigning. Then you type here, so it is fast Ethernet. Now we have to select serial 0/0/0. This is the port that is appearing here. So we have decided what IP address will give, 12.0.0.1. The subnet mask will appear. Click to this port status, it should be on. So it is a class A IP address. You can see the subnet mask, right? Close this. Now click to the other router, select the serial port and write the IP address here. What IP address we wanted to give for this? 12.0.0.2. right, so here we'll check, yes, the IP address. Now you make the port status on. So the ports which were earlier in the red color has become in green color now. The state is up. Here also the state is up, and the other side of this router, router 1, and the other side of this router, router 0, even these IP addresses need to be configured. So we'll do first for the router 0, and the port is fast Ethernet 0/0, and what is the IP address? 192.168.20.1, and type subnet mask will appear. Make this port status on, close. Now similarly for this router, router 1, this interface has to be configured. We'll go to this fast Ethernet 0/0 and type the IP address. So what is the IP address? 200.0.0.1. okay, so the subnet mask has appeared, port status to be made on. You can check here, all these interfaces are in green color, so the status of all the lines is up here. So after you carry out these things, next is we need to now enable NAT. We need to enable NAT in this router. So enabling NAT in this router is simply click to this router, go to the CLI mode, okay, and there you type few commands, and all these commands should be typed in the global configuration mode only. So here what is that you have to do exactly, I'll just show with the diagram. This router, it has got two interfaces. One interface is in this private side, the other interface is connected to the public. So in this private side, what you have to do is this interface number you need to configure it as inside. So what I'll do is I'll type the interface number int FA 0/0, and I will write the command ipnat inside. ipnat inside. Why I am using this word inside is this interface is inside to the private side. Then exit from this and now try to write the command for the other interface, serial 0/0/0. So now once again type the command int serial 0/0/0, then you have to type here IP NAT outside. Now this interface is outside the private site. So these are the commands in Cisco Packet Tracer for the NAT. Exit from the interface mode. Now one more thing you need to remember is this is a static NAT. That means for every private IP address there is a public IP. So that public IP what you want to give for every private IP you need to type here. So the command is IP NAT inside source static. Now type the private IP addresses which you have chosen for your private site 192.168.20.3, and for this private IP address you want to map it to a public address. So we'll take in this range 50.0.0.1. How many PCs I have in my private site? 3 PCs. So for all the 3 PCs I need to give a public IP. So what I'll do is, to make it fast, I'll copy this command, paste it. What I'll do is, for the rest of the 2 devices, let me do it here. I'll give for 20.4. So for 20.4 I'll give 50.0.0.2. Okay, 20.4. So for the second PC we have completed. Now we'll carry out for the third PC. .5, right? So this way, if you see this command lines, what is that you are observing? Since you have 3 PCs, 20.3, 24, 20.4 and 20.5, for each of this PC you have assigned a public IPv4 address 50.0.0.1, 50.0.0.2, 50.0.0.3. So you have decided that you, from one pool of public IPv4 addresses, you will be assigning to this private IPv4 addresses. Fine. So once you do this one-to-one mapping you have done here in the static NAT, you need to now verify the working of the NAT. So we'll try to ping from one of these PCs to the server. So now we'll verify from PC0 whether PC0 can communicate with the server. Click to PC0, go to command prompt and type ping the IP address of the server 200.0.0.10. This is what is the IPv4. Now you can see, yes, the reply has come. So it is a successful communication. This private IPv4 address now can communicate with a public IPv4 address. And this is possible because the router which is connecting the private site is now enabled with NAT. All the commands that are required here in order to configure for the static NAT has been done for this router. So this router is taking care of this translation. So what exactly the translation happen is, this router, when it receives a packet from PC0, it is receiving the source address as 192.168.20.3. The moment it wants to send this packet or forward here to this interface, it will replace this source IP address with 50.0.0.1, the one which we have assigned here in the router configuration, the public IP address. So it is replacing this source IP with another public IP. So that becomes the source here from here onwards. From this path onwards, that becomes the source. Similarly, when the reply comes back, the router takes care and it will replace that public IP address 50.0.0.1 with what? 192.168.20.3, and it will reply to this particular PC only. So this way the translation is carried out. And if you want to see static NAT table, you can always use the command show IP NAT translations. So click to this router. In the privilege mode, you need to type show IP NAT translations. You can see a table here. Look here, what is that? Inside local 192.168.20.3, 20.4, 20.5. These were your IPv4 addresses for all these private IP. Okay. And the mapping is here. For 20.3 it is 0.1, for 20.4 this one 0.2, for 20.5 0.3, like this you have done the mapping. Now since there are 3 PCs, only 3 rows are appearing. If there are 10 PCs in this private site, then 10 rows will appear in the table. So this is all about the static NAT. But one disadvantage of static NAT is, for every private IP you need to give a public IP. That means what, you are not able to save the public IPv4 addresses, and also this is reserved always. This 50.0.0.1 is always what, is always for this 192.168.20.3. even if 192.168.20.3 is not sending any information, or that means it is idle, even then this public IP 0.1 cannot be used for any other PCs. So that way you are wasting the IPv4, public IPv4 addresses in static NAT. Whereas we have one more type of NAT, dynamic NAT. To overcome this issue only, we go for the dynamic NAT, and I have a complete session on dynamic NAT in my computer networks theory series. You can watch that session. Hope this session is useful to you all. If you find it useful, please like, share and subscribe to my channel. Thank you. Bye bye and take care.